I'm Schmitt, Apollo 17 astronaut and geologist. Flew on the Apollo 17 mission in December of 1972. The crew of Apollo 17 was an aggregate of two backup crews, Apollo 14 and 15. I replaced Joe Engle on that crew, and Gene Cernan would be the commander. And Ron Evans was going to continue as the command module pilot. Gene Cernan got out of the spacecraft first, and I followed him fairly quickly afterwards. We were in a valley deeper than the Grand Canyon of the Colorado. The mountains on either side were 2,100 meters, or about 7,000 feet high. The sun was as brilliant as any sun that you can imagine. Even more impressive was the Earth, which was hanging over one of the mountains and stayed hanging over that mountain, the South Massif. And that was really a magnificent sight for me, and that's what I remember as being sort of my first real impressions of the Valley of Taurus-Littrow. After the deployment of the Apollo Lunar Surface Science package, we had enough time for an abbreviated exploration traverse that originally was supposed to go out to a crater called Powell. However, we had to cut that short, and we stopped that traverse at a crater known as Steno. Steno was a place to gain samples of the upper part of the basalt lava flows that had partially filled this deep mountain valley called Taurus-Littrow. We also, during that excursion, realized that we couldn't continue to drive without the right fender. Now, what happened to the right fender? Well, it was broken off when Gene Cernan walked by it with a hammer in his pocket and hooked that hammer around the fender and broke it off. That created a sort of rain of dust down on us and our equipment. Now, when we left the lunar module on the second excursion, we carried with us down the ladder a new fender that was made up of the photo maps that we had in the cabin, taped together with gray duct tape, as you might expect. We headed out as fast as we could to get as far away as we could within the walkback envelope for any kind of rover failure that would require us to walk or run back to the lunar module. That took us about 7 kilometers from the lunar module to a point within what is actually a moat that surrounds the base of the South Massif. The large crater known as Nansen is not really an impact crater, but a particularly prominent part of that moat. Station 2 at the eastern end of Nansen was selected by me as a place where there were numerous boulders that had rolled down the side of the South Massif. I was headed down the slope back to the lunar rover, and I noticed out of the corner of my eye a light greenish inclusion or fragment in another boulder, and skidded to a stop, went back and sampled that inclusion, which turned out to be dated back here on Earth radioisotopically as having formed 4.6 billion years ago. Well, that's a little bit older than the moon, and so the error in that date has to be something a bit larger than normal, but nevertheless it was formed soon after the moon itself formed. So that was one of the more important samples that we found on the entire mission. Station 3 on the edge of the crater Lara, recognizing the writing talents that produced Dr. Zhivago, actually became known as Ballet Crater because I ended up spending a lot of time wallowing around in the lunar dust trying to recover samples I had dropped. What looked like an impact crater had penetrated the light mantle and thrown up a relatively dark material onto its surface. This was the crater Shorty, Station 4. But within the resolution we had, it was not absolutely certain in our minds before the mission that Shorty was an impact crater. It might have been one of those volcanic craters we were looking for that would have been the source of these volcanic glasses, the pyroclastic glasses that had partly led us to select Taurus Littrow as a landing site. Indeed, it was an impact crater, and as I walked up to it, I noticed that the regolith, the debris layer at its rim, had an orange cast to it. And so I began to dig into that rim and uncovered these orange glasses, the so-called orange soil, and that has become so prominent and important in our considerations of the origin of the moon. As we approached the base of the North Massif, we got even a better view than we had had from the lunar module of the boulder tracks that had been left by large boulders as they rolled down the side of the North Massif. The one boulder we did visit at Station 6 was big enough to give us a contact between an older blue-gray rock made up of fragments of other rock, or what we call a breccia, that had been intruded by a tan-gray breccia that had partially melted, been partially melted by the impact that formed the Serenitatis basin. That has given us a date for the Serenitatis basin forming event of about 3.87 billion years. On the way back to the lunar module, after the work at Station 6 and two other stations along that mountain front, the plan was, and indeed we did go to a station known as Van Surg. The Van Surg name came from a pseudonym that a professor of mine at Harvard, Hugh McKinstry, used as he published humorous documents sort of poking fun at science and geology in general, such as the use of math to confuse people. But Van Surg was another crater that we thought might be a volcanic crater. When we got there, indeed, it turned out to be an impact crater. After some sampling and work at the rim of Van Surg, I then, going back to the lunar rover, made very, very good progress with this cross-country skiing technique. I was probably moving about 10 kilometers an hour through this boulder field. So it really shows that human beings are going to be very, very adaptable very quickly to working in strange gravitational environments. The Apollo Lunar Roving Vehicle, or LRV, was a very, very effective field vehicle for us. It weighed about 450 Earth pounds. You could drive it about 12 kilometers an hour. That speed was sufficient. It seemed a lot faster than it sounds, because every time you hit a bump in 1/6 gravity, you'll bounce off the surface for a while. We took it up to 18 kilometers an hour down a ridge and decided that was probably a little bit too fast. But it has been realized for a long time that if you have a pressurized rover that allows you to use consumables that you carry on the rover, you not only can increase your distance away from the lunar module, but you can think about going several days. Recently, that concept has taken form in a pressurized rover that is large enough to normally have 2 astronauts working within it. In an emergency, could take up to 4 astronauts, and would allow those astronauts to make critical judgments on where they were going to work before even getting into their suits and getting out onto the lunar surface. All in all, it looks as if the ability to have a pressurized rover on the moon will add significantly to the return of exploration missions. By far the most important thing that Apollo did was that it demonstrated that human beings can now live in the solar system. They can explore and establish themselves as creatures of the moon and of Mars and who knows where else in this beautiful solar system.